Good morning. I am Suhasini Goilkar. Now, in this my fourth presentation for OER activity, I am giving here the presentation on voltage and power distribution of AM wave. In the previous three my presentations, I was given the presentation on amplitude modulation basics, details, its expression and types of amplitude modulation depends on the modulation index. Now see the voltage and power distribution of AM wave. In the communication system, when the information transmit from source to destination, it is very important. The power distribution is very important. Now that's why the voltage and power distribution of amplitude modulated signal is very important. Now see the voltage and power distribution of amplitude modulated signal. See here voltage distribution of amplitude modulated signal. As we know, in the amplitude modulated signal, the carrier signal is there, lower sideband is there and the upper sideband is there. What is the amplitude of carrier signal? It's a VC, means this is the voltage distribution of carrier signal. Then lower sideband MVC by 2. This is the voltage distribution of lower sideband, and the upper sideband, that is MVC by 2. This is the voltage distribution of upper sideband. Now see the power distribution of amplitude modulated signal, means double sideband full carrier signal power distribution. See here, this is P total is equal to, as we know, see the in the frequency spectrum, carrier signal is there, lower sideband is there and the higher sideband is there. Means it is the summation of P carrier plus P USB plus P LSB. Now take it in terms of V and R. R is the load resistance, means it is the antenna resistance. It is also called the power dissipated power, antenna in which the power is dissipated, loss of power. Now see here, it becomes V square by R carrier plus V square by R USC plus V square by R LSB. Now find separately the carrier power, USB power and LSB power. The carrier power is denoted by PC. PC is equal to V square R carrier. The average power, first find the average carrier power, and as we know, the average power or the RMS power we are finding to take a divide by square root. Means suppose for example VC is equal to, it is average power, RMS power, VC is equal to voltage, it is equal to VC divided by square root of T. 2 means here PC is equal to, it becomes VC divided by square root of 2 whole square divided by R. Means here the carrier power PC is equal to VC square divided by 2R. Now see the powers in sidebands. As we know, the sideband powers PLSB and PUSC both are the same. So here average power for two sideband is PLSB is equal to PUSB is equal to VSB, means sideband square divided by R. And as we know, VSB means here in the two sidebands it is MVC by 2 divided. So put here the RMS power. So it becomes MVC by 2 divided by square root 2 whole square into 1 by R. Means here PLSB is equal to PUSB is equal to M square VC square divided by R. Now see the total power. Total P total is equal to PC plus PUSB plus PLSB. Means put here all the values. It becomes VC square divided by 2R plus M square VC square divided by 8R plus M square VC square divided by 8R is equal to VC square divided by 2R in bracket 1 plus M square by 4 plus M square by 4. It becomes VC square divided by 2R in bracket 1 plus M square by 2. Therefore, P total is equal to VC square by 2R, means it's a carrier power. Means here the total power of AM modulated signal, it is equal to PC in bracket 1 plus M square by 2. Now see here, this total power here it is in terms of carrier power and modulation index. So here easily it is possible to find the modulation index in terms of PC and PT, means total power and the carrier power. Now the total power is equal to PC in bracket 1 plus M square by 2. Simplify it. It becomes P total by PC is equal to 1 plus M square by 2. Now M square by 2 is equal to, it becomes P total by PC minus 1. and m is equal to here square root of 2 in bracket p total by pc minus 1. This is the modulation index in terms of total power and carrier power. Now see the effective voltage and current for AM modulation wave. Now first see the basic formulas. P is equal to, what is the basic formula in terms of V and I? P is equal to V into I. P in terms of V, what is the formula? P is equal to V square by R. And P is equal to, in terms of current, I square R. Here V is the voltage at antenna and I is the antenna current. Now as we know, P total is equal to PC in bracket 1 plus m square by 2. P total is equal to, in terms of V, it becomes V square by R is equal to Vc square by R in bracket 1 plus m square by 2. Therefore, Vc square is equal to, it becomes Vc square in bracket 1 plus m square by 2. And V is equal to Vc in bracket square root of 1 plus m square by 2. Means here P total is equal to I total square into R in terms of I. This is the voltage distribution. Now find the power current. PC is equal to IC square into R. P total by PC is equal to, as we know, 1 plus m square by 2. I total square R divided by IC square I is equal to, it becomes 1 plus m square by 2. Means here I total by IC whole square is equal to 1 plus m square by 2. I total by IC is equal to square root of 1 plus m square by 2. And I total is equal to IC in bracket square root of 1 plus m square by 2. Here it is possible to find the total current at the antenna, and as we know, in the transmitter section at the end, after using the amplifier, mixer, synthesizer, power amplifier, voltage amplifier, all modulator, all circuits, oscillator, all circuits, the antenna is there. If we are using the wireless communication, then the total current, total power fed to the antenna, that is the transmitting antenna, and from that transmitting antenna, by using the free space in the wireless, by using the free space as a medium, the power is transmitted. Means our information is transmitted from transmitter to receiver section. So these are the total power distribution, current distribution, effective voltage in terms of modulation index and in terms of carrier power. All these are the expressions. Now see here modulation index in terms of current. I total is equal to, as we know, IC in bracket square root of 1 plus m square by 2. Now take here the square root of 1 plus m square by 2 is equal to I total divided by IC. 1 plus m square by 2 is equal to I total square divided by IC square. Here simplify it, we will get here the m is equal to square root of 2 in bracket I total square divided by IC minus 1. This is the modulation index in terms of total